Hello everyone, my name is Waj and I am a researcher from the SRT department. Today I am presenting my methodological undertaking for the course Qualitative Research. This is where, for the first time, I stepped out of my comfort zone in deep learning and building satellites to explore the qualitative perspectives of domain experts. My project is titled Bridging Deep Learning and Volcanology on Board. The agenda for this presentation mirrors the qualitative research process. First, I will contextualize the project, why a satellite engineer needs qualitative data, for instance. Second, I will detail my methodology, especially purposive sampling, netnography, and reflexive thematic analysis. Third, I will visualize how I moved from raw text to meaning. And finally, and perhaps most importantly, I will reflect on the challenges I faced as a researcher and discuss how alternative methods might have changed my results. So let's start with the context. My PhD work focuses on deep learning for onboard satellite processing, especially detecting volcanic eruptions. Usually, we build such systems based on technical metrics like accuracy, latency, and compression. But thanks to this course, I realized there was a gap. We cannot build a useful system without understanding the humans who use the data, right? So my research question shifted from how do I optimize the system to what are the prominent challenges and opportunities that volcanology expert acknowledge in satellite-based monitoring. So this required a qualitative approach to understand the priorities and not just the statistics. To answer the research question, I used a triangulation strategy for my data collection. I employed purposive sampling. I wasn't looking for random people. I needed specific experts in the intersection of remote sensing and volcanology. And my data came from two important courses, semi-structured interviews and ethnography. So in semi-structured interviews, I conducted deep dive interviews with practicing volcanologists. This allowed me to ask the why questions and follow up on the technical nuances. And in ethnography, I analyzed a few pre-recorded expert technical presentations where I treated these data as naturally occurring data and where this was unobtrusive, and I could also observe how experts talk to each other when the researcher isn't interrupting them like someone like me. So from the data that I collected, I could have a mix of an interview with recorded presentations, which gave me both an interactive perspective and a passive observational perspective. So for data analysis, I choose reflexive thematic analysis. I choose this over a simple word count because I wanted to identify patterns of meaning. My process involved um, deep familiarization, reading the transcripts multiple times, followed by open coding. For example, when an expert mentioned interferometric SAR or thermal IR, I did not just ignore it as a jargon, I coded it as a data source type. When they spoke about pre-eruptive periods before the wake, I coded those as early warning priority. And this was an inductive process. I let the data drive the themes. So from all the data analysis that was done, four key themes emerged. The first theme stresses the data integration. Experts emphasized that no single sensor suffices for deep learning models. Instead, a multi-sensor approach is necessary. Combining optical, radar, and infrared data would give a comprehensive picture of the volcanic activity. The second theme that emerged was the primacy of pre-eruptive warning. Experts prioritize detecting subtle pre-eruption signals such as deformation and magma movement ahead of any eruption event. The third theme also focuses on near real-time imperative. The utility of a satellite data sharply declines if the information arrives a bit late. Experts stressed that alerts must come quickly. Delays of even days render the data less useful for hazard response. So the fourth theme emerge is the operational challenges and limitation. For example, equatorial cloud cover, atmospheric haze, and orbital gaps, which frustrate the experts relying on continuous clear imaging. So these physical constraints must be accounted for in the deep learning models and operational workflows when we operate the satellites to have them to maximize the usability. So together these themes outline that effective volcanic hazard monitoring demands integrated multi-sensor data, early warnings, rapid delivery of data, and minimize the environmental challenges. Okay, this slide further complements the themes that we discussed in the last slide, giving a sense of the richness of the data that was collected. Two paraphrased sentiments shown in this slide stood out for me. The first quote validating the need for my model to focus on subtle signals. The second quote highlighting the human anxiety regarding the data latency. So, building on those themes, this mini venture also revealed a few important challenges and limitations in my own study. First, the sample size. It was deliberately kept small to a few, three interviews and a few videos. Therefore, it is hard for me to claim that all volcanologists think this, but instead, I try to offer depth and transferability supported by triangulation across multiple sources. Second, there was an insider-outsider dilemma. Coming from a positivist technical background, the instinct was to engineer neat, objective answers rather than treat them as situated perspectives. So, staying reflexive, catching the impulse in real time was crucial here to keep the to keep the qualitative study going. At the same time, being an insider also helped. For example, technical concepts like INSAR coherence and all these codings didn't break the flow and kept the conversation going. So, coming to the reflection on alternative methods or consequences of my methodological choices, if I had taken a qualitative content analysis route, I would now have clean tables and bar charts showing the SAR was mentioned 40 times, optical was mentioned 10 times, and the latency was mentioned 15 times. That would look a bit rigorous and a bit deep, but I feel that it would take out the human element out of it and or reduce the human element into some data points. This is what I can reflect. Uh, the other part, if I have done the quantitative survey, that would have offered the opposite strength, where I could generalize with responses from 50 scientists. I could have confident statements about percentages and correlations and so on. But time. Surveys require the researcher more or less knows the landscape or in advance. So I would have pre-written maybe a questionnaire. In doing so, I feel that I think I would miss the some key points. For example, the points where the scientists could share their frustration with environmental conditions in equatorial orbits and haze and so on. This is something that I would miss if I would just I feel if I would just do a questionnaire. Finally, to conclude, this qualitative venture turned out to be for me much more than a side project. It was foundational for the technical work that I've done. It showed clearly that the satellite tools are truly valuable for volcanologists when they especially help detect the quiet pre-eruptive signals that come before an eruption. At the same time, this study also opened up wider questions. For instance, how should technical expertise be balanced against the qualitative bias? And in the ethnography context, how far can pre-recorded video data stand in for live interaction while still claiming depth and authenticity? I would like to reflect more on these questions. And once again, thanks a lot for your time and listening. I really enjoyed this course. So, finally, these are all the references that I used to base these slides from. Once again, thanks for your time. Bye.